Hi, I'm Alex Peters, an RFID consultant in healthcare and pharma, and I'm going to be pressure tested on 20 questions relating to RFID. So what is an asset? Well, in our world, an asset could be anything that you can track with some sort of tag or a label. So that could be in hospitals, a medical device, that's one I work with a lot. It can be a person, a patient or a staff member. It can be a piece of stock or an implant, a consumable. Anything that you can track and tag is an asset to us. Why is there a need for asset tracking? I think predominantly it comes down to efficiency in most industries, cost savings. There are a lot of benefits regardless of the industry. I specialise in healthcare, but across the board, aviation, retail, production, it usually comes down to cost savings and efficiency. In our world, there's also a bit around patient safety as well, and the end use benefits that you provide to that patient. So yeah, it can be anything from reducing costs, maybe replacing assets, making sure your staff are finding assets quicker, that you've got the right availability, reducing wastage from things expiring, having the wrong batch numbers. Also from a safety perspective and audits in healthcare, we get a lot around assets that need to be found and recalled, maybe brought back for service or maintenance or repair. So it's just about efficiency all around. How are assets typically tracked? It can obviously vary between different industries and even different organizations. Everyone has their own way of doing it traditionally. Barcodes have been a long-standing way of doing that for a number of years now, for decades. A lot of people will do audits, so they go to their locations, they'll do audit counts and inventory checks of what they have, update the location that way, and then that will be the record until the next time you go and scan it to see, is it still there or has it moved? And if it's moved, you try and scan it the next place it turns up. Obviously, the downside of that is that you don't necessarily know that something is accurate until you go back and check it again. So RFID is all about improving the reliability of that data, the integrity of what you have with your location, your inventory counts, making sure that it's either real time or as close to real time as it can be. So asset tracking in healthcare, what is the biggest challenge? I think from what we see, and we're speaking to customers in various hospitals, it's the sheer number of assets. A typical trust will have in the region of maybe 20 to 30,000 assets. Some have a lot more. And these can be very big organizations, multi-floor buildings, lots of maybe different community sites spread out across a large area. So trying to keep track of all those devices, especially when they're moving and being used daily or multiple times a day, can be a real challenge. And that's where we try and help, is really pin down where are they for clinical use in healthcare settings, and also for the engineering use, the people that are maintaining and servicing the equipment, to make sure it's ready to be used by clinical teams. What is the most interesting or intriguing thing that I've had to track? For me personally, it's probably quite boring. It's all medically related devices. I have heard some stories from colleagues in different parts of the company, in different industries, that we've tracked bees, for example, or wine and cellars for presidents in other countries. But for me personally, it's probably, I'm a bit of a techie person, so I like tracking the really small, tricky stuff. And we've had devices that can go through autoclave sterilization processes. And I just love seeing how small can we get the tags, what's the most extreme environmental factors that you can throw at a tag and have it survive and still be functional after. So for me, it's probably that, it's the small surgical instruments. So what is RFID and how does it work? So RFID stands for radio frequency identification. And it's very similar to a barcode in that the ID part, it is a tool for identifying something, usually an asset of some sort. And the RF, the radio frequency, is the technology that we use to do that. So RFID operates at various different frequencies. One of the most typical is ultra high frequency, which in the UK is just below 900 megahertz. And with a passive tag, the way it works is you have in your label or your tag, you have a microchip and an antenna. You then have some sort of external exciter, which emits that ultra high frequency, so it creates a sort of a radio zone. So that antenna emits basically a radiated zone, and when that tag enters that zone, the antenna becomes energized. It then has enough energy to give off its own signal back, which transmits the data in that microchip. So the antenna picks up the same signal, it listens and responds, it detects multiple tags at the same time, and then it can identify the tags in that radius. Then once we've detected that, we basically push the data back through the network to our software, where we collate all of that information. We can integrate with existing systems in that organization to say, these are the assets I found. Are there any correlated fields that we need to be aware of, like alerts, expiry dates, batch numbers, anything outstanding? And then we can flag alerts on those assets as we see them. So one question we have is, I've seen metal foil tags on products when I go shopping. Is this RFID? Most likely, yes. So you'll be surprised how much RFID surrounds you in everyday life. When you go shopping, you'll see a lot of products now do have these small labels, potentially foil, or they can be paper-based as well. Sometimes you might actually see the antenna. It's sort of like a metal squiggly shape embedded into that label. And that's exactly it. That's the antenna, which when you walk out the shop, you have the sort of barriers at the exit. They are emitting that ultra high frequency signal, so that as you pass through, the tag becomes energized, it responds back, and if it's not being deactivated, then it will alarm the system. There are lots of other areas in everyday life where you'll use RFID as well. So everything from your banking cards, your contactless, that's NFC, which is all part of RFID. Your phone uses it for contactless car entry. And if you use tolls across bridges or tunnels, you may have a tag in your car. That's also a form of that as well. Another use case that's very common is clothing and retail. So a lot of brands will now have RFID tags embedded into the labels of your clothes. The purpose being is that once that shop floor is full of all the inventory, you can have overhead antennas, which are basically scanning that in real time. Or it could just even be a handheld device that a member of staff takes around, and then they can do an inventory check or an audit of all of their stock in minutes, rather than having to manually go through and check each label or each product one at a time. What is the difference between RFID and barcodes? Well, I like to think of RFID as an evolution of the barcode. So obviously the barcode has been around for a number of years now. And a barcode is great. It serves an amazing purpose, and it's revolutionized the way we manage our inventory across various industries. But it does have its limitations. One of them is that you need line of sight. So every time you scan a barcode, you need to physically see it to read it. The other one is read range. So you have to generally be quite close. You can maybe get a couple of feet away with some scanners, but you still have to be in close proximity. And of course, you can only scan one barcode at a time generally. So it's a one-to-one relationship to check that asset and check what it is. And so RFID basically evolves on that. We take the line of sight and we can now read through various materials, anything except fluid or metal. So if you've got stock in cupboards, behind walls, doors, in inventory storerooms, you can basically blast the RFID signal through any material except metal and fluid, and you can read that tag without physically seeing it. The read range is also massively improved. So with UHF, you can get up to 10 or 11 meters away and be able to read that tag. And with active systems, it can be hundreds of meters or potentially more. The other great benefit of RFID is that we're not limited to that one-to-one relationship. Most systems can read up to 1,000 tags per second. So if you have a load of inventory, wherever that may be, you can go in with a handheld scanner, or you can have a fixed scanner, and you can read hundreds or thousands of tags per second, and you can get really accurate, reliable information about everything that the system is seeing. Can RFID really tell me where every medical device is? It can do. One of the biggest things we usually get is obviously budget, especially in healthcare and the NHS in the UK. We know that that's one of the main constraints at the moment. But yeah, without doubt, if you have the budget to get the best infrastructure, you can, in theory, find out where every medical device is, potentially in as close to real time as possible if you need to as well. What we tend to do in reality is we find a balance. So there's somewhere between the functionality of the system and the budget of what can be deployed. There's never a single use case or a single tag that covers all use case. We're always looking for a hybrid approach. So it might be that some assets require cost-effective passive tags, which can be deployed in their thousands. Some assets may require a higher value active tag, which gives you more real-time information, but comes at a higher cost. So we'll always look for a balance to get that right, and make sure that the assets that are the highest priority for you, we can give you the best information. And for those where you don't necessarily need to know as much data, we can still track it, but it's not necessarily essential to know every minute or every hour where that is. Is RFID safe to use in healthcare environments? This is one we get a lot of the time, especially with obviously a lot of sensitive medical devices and patients potentially being exposed to that. So the generalized answer is yes, it's completely safe. RFID operates at a specific frequency, just under 900 megahertz here in the UK. That varies by region, depending on the regulations and the country that you're in. But the important thing is that, firstly, that frequency is regulated. So it's a defined bandwidth for this application. and in the UK that's regulated by Ofcom. So with medical devices, they generally have some sort of shielding as a first barrier anyway, but then also that difference between the frequencies makes sure that they're not going to interfere with any of the systems or radio channels that they may be using. From a patient perspective, RFID is also very controlled and regulated in terms of how much power you can emit through these systems. So we basically have maximum settings. And even if we have a system with multiple antennas in close proximity, what you will generally have is multiple antennas being controlled by one reader. So the reader is basically the brains that powers the antennas and collects all the data that they're emitting. And at any one time, if you have, say, 10, 20, 30 antennas connected to one of these centralized readers, what it will actually do is just emit power to one antenna at a time, rather than emitting all of them constantly. So it cycles through all of the individual antennas and makes sure that any one of them at any given point in time is not emitting more power than it's regulated and allowed to do so. What's the difference between passive and active RFID? Again, this is one of the biggest ones we get, and RFID can be a very confusing field to get into when you're first exploring it. And there's a lot of terminology that gets thrown around, and this is one of them, is active against passive. So the simplest way to describe it really is passive is an inert tag. That means it doesn't have a battery, and active does. So a passive tag needs some sort of external exciter or energizer to make it work, to give it the energy to emit its signal. Whereas active needs a battery to make it give off its own signal. It can work independently of infrastructure around it. So a good example of an active tag would be an AirTag that you have if you have an Apple device. It's got a battery inside, it's emitting its own signal frequently. When it comes to functionality, one of the main differences is the read range. So with passive labels or tags, the longest ones you can get about 10 to 11 meters typically. With an active tag, it's a much more powerful signal because it's got the battery, and that can be potentially a couple hundred meters, so you get a lot more flexibility in how far you can detect those. That also means the infrastructure is slightly different as well. So with passive, where you have those external energizing devices, whether it's handhelds or fixed readers, they create basically localized zones. So you detect something in situ, you say that's the lasting location point. But with active, you need a different infrastructure to listen to those what we may call chirps or signals that are being sent out. And with active, therefore, you can get more of a real-time location system. They can be a lot more frequent. The tag can be chirping its signal from anywhere in your organization, so you can be a bit more precise and up to date with where it's at. So what are the smallest items that we can track with RFID? We can get pretty small, down to a few millimeters in terms of tag size. The natural caveat to be aware of whenever we talk about this is that, as a general rule, the smaller the tag or label, the less read range you're going to have. So that does play into the limitations of the functionality a little bit. One really good use case is sterile instruments. So we can, if we need to, track individual instruments with very small tags that are custom built to withstand the processes that they go through with sterilization, etc. But then, of course, the limitation of that is the read range might only be, say, 15 centimeters. So then it becomes more of a maybe an audit check, an inventory check, or a kit completeness check. That's something you could do with a handheld where you're in close proximity and you're going over a tray of surgical instruments to make sure everything is complete and ready to be used. But then, for example, you couldn't track those instruments as they're going down a corridor with an overhead reader. It just wouldn't have the range to be able to do that. There are some tricks we can use to get around that. So we can do things like parent and child relationships, where assets with potentially small read ranges are assigned to a tray or a container which has a larger tag. That large tag then has the longer read range, and by tracking the parent and allocation of stock, we can then make assumptions on what contents or children are contained within that asset. How reliable are RFID tags, and do they fail? Again, it depends on, I think, the technology and the tag choice. There's very rarely a use case that can be achieved with a single tag or a tag type. It's usually a mixture of different tags and options. So you might have some use cases. We have customers where the tag only needs to have a lifespan of a few days. So something comes in, it goes through the processes, then it's disposed at the other end. In that case, we're looking at probably a paper-based label, very short lifespan. It can be damaged easily, but it needs to be, because it needs to be cost effective because they're being disposed at the end. At the other end of the scale, we need tags that can withstand really extreme environmental factors, whether that's in industry and construction, or sterilization and autoclave, which I've mentioned. where tags are needed that can withstand extremely high temperatures, very toxic detergents, steam, pressure, humidity, etc. And naturally that means that those tags that are built to withstand that will cost more than your sort of middle tier or even disposable ones. So they can withstand very extreme conditions. There's always a variation of tag for different markets and use cases. Many tags can last a number of years, potentially 10 years or more, but going all the way through use cases, you can get some that just last a few days if needed. Is RFID the same as NFC, and what technologies does it cover? So NFC is a type of RFID, RF being radio frequency, that covers quite a wide spectrum. NFC is one of those, so near field communication, that's what you'll experience with your contactless cards or paying with your phones. But there are various other technologies that come within the sphere of RFID. UHF is one of them, and probably one of the most common for standard asset tracking and tags and labels. That's ultra high frequency. You can also use Bluetooth and Wi-Fi at the sort of 2.4 gigahertz range. GPS may also be considered as a type of RFID, where we're tracking assets going out into the community or even globally. And then between all of those, there are some other sort of variations of Bluetooth, for example, where there's Wirepass is a good example, running on the same frequency, but slightly different in the way that it works behind the scenes. So yeah, overall, RFID encompasses various technologies. NFC is one of them, but we'll always look to use potentially a mixture of them depending on the use case that we have in mind. So this question says, I'm not a technical person. Is it hard to implement RFID technology? Generally, no, it can be quite straightforward. So at a very basic level, you can just start with some tags or some labels and a handheld reader. And a handheld reader is basically an Android phone that has an antenna built in, and then there'll be an app on there that can scan those assets and tell you what it's seeing. We can then sort of step up from there. So you can do an integration maybe with an existing database where those assets are stored. So if you're working with medical devices, you might have a database that contains all the service history and maintenance records for those devices, in which case we can integrate to that and pull that information down so that when we scan a medical device, we'll do a quick check with that database and say, is there anything outstanding with this device that the user needs to see on the screen? Additionally, on top of that, you can start to expand infrastructure. So we can do automated antennas or choke points, conveyor belts, smart tables, smart benches, or even cabinets that can basically do all of this detection for you. So it removes some of the manual processes involved. But generally, that's something which, if you're implementing RFID, there'll be teams that support you with all of the technical stuff in terms of setting up the system and the software behind the scenes. Generally, the end users, all they have to worry about is physically tagging the devices. So in my role, for example, I spend a lot of time speaking with people and giving them best practice on how to label a device, how to find the best positions, how to think about considerations which will impact basically the functionality of that device to make sure the read range is as good as it can be, making sure that they're aware of the limitations with metal or fluids that could reduce the read range. And once you've then got a process in your organization of how to relabel the devices, and there's some just general knowledge and good practice of how to use the system, the actual deployment and then scanning and using the system is very user-friendly and very easy generally. What are the common things that we should see post RFID implementation? So yeah, there's a couple of key ones. One is that you're going to be able to obviously find devices quicker. That's the main hope. And that has a couple of knock-on impacts. So from a clinical perspective, we know from surveys that have been done that nurses spend an average of 1 hour per shift looking for devices. And that obviously means it has an impact on how quickly you can diagnose, treat, and ultimately help a patient recover and be discharged from their stay in hospital. So from a clinical perspective, it's all about making those devices more readily available. That can be through either logging onto the system and seeing if what's available in neighbouring wards. A lot of devices will have medical equipment libraries, so they can log on and see what's in stock. They can potentially check the status of any devices that they've sent down for repair or maintenance as well to the engineering teams. From that perspective, it's all about speeding up the availability of devices and making sure that they can do their job as effectively as they can. From an engineering perspective, there's also a lot of benefits in being able to locate those devices when they are due the maintenance. So rather than having to go towards and seek things out, you can proactively make plans on what you're going to be looking for and when. If there's any recalls from the manufacturer or the MHRA, it makes it a lot more responsive to be able to identify where those assets are and proactively go out and find them and perform the corrective actions. And I think also from a sort of procurement and contracts point of view, it gives you a lot more data and visual awareness on the integrity of what you think you have versus what you actually have. So when you're planning about rolling replacement programs or bringing in new medical devices, you can have a much better understanding of what you need to be able to fulfill the needs of your operations and also make sure that your cost savings or cost spending is as effective as it can be. So then what we generally find is once the first use case is being embedded and staff have awareness of what it can do, that can roll out very quickly to other use cases. So I talk about asset tracking medical devices as one of the core ones, but then that can roll out into other departments, maybe IT equipment or estates or facilities. It can be used for stock control, implants, drug management, maybe samples in the labs. And so I think that's where we start to see systems roll out and grow gradually, is that other use cases, other departments will pick it up. And then those same sort of benefits, efficiencies, cost savings that you may see with medical device tracking can be expanded across those other aspects as well. Which medical devices are most commonly tracked with RFID? I'd probably say infusion pumps are definitely up there. We have a lot of interest in bed tracking. We all know that the NHS is struggling for beds at the moment, and there's a lot of stuff in the news about that. So being able to know where beds are, what is the status of them, are they clean or dirty, is there any damage to them, etc. And also feeding into the bed bays and availability of that. That's something RFID systems can help with a lot. But yeah, infusion pumps are always highly in demand. I think that's one where if a medical equipment library is being used, that's always probably the one that's most out of stock. Bladder scanners are always in high demand. They seem to be probably one of, if not the most mobile medical devices in the hospital. It's constantly moving, it's constantly being tracked. And yeah, I suppose anything for diagnostic use generally is something that gets moved around a lot. So we get a lot of those. So what is the relationship between RFID and patient safety? Well, I think RFID can touch on every aspect of the way a hospital runs that directly impacts patient safety. One of the main ones, of course, is the assets themselves. I think when you walk into a hospital for yourself or a loved one, you have some very basic expectations. One is that there will be doctors and nurses, that they'll have the right drugs and medications, and that they'll have equipment that is not only available but also functioning properly. So RFID allows you to firstly confirm what you have with good integrity, make sure you have the right equipment in the right place, but also ensure that the teams looking after that equipment can service it, maintain it, and calibrate it to make sure it's performing as you'd expect it to. So that's the most obvious one. It has a direct impact on the care that they receive, not just from physical people, but also the hardware and the equipment. So the next one is, can you embed RFID technology into our existing asset labels? Kind of yes and no. So the ones you physically have already, it's not like we can take those and sort of retrofit them with RFID. It's just much easier and simpler to basically issue new asset labels with the RFID embedded in them. For all intents and purposes, they will look exactly like your existing asset labels do now. They're just a sort of thin plastic coated label with your logo and the equipment number on, maybe some additional text. And most people would never know that it's an RFID label, but embedded within that we have a microchip and an antenna which responds to fixed or mobile readers going around and doing the inventory checks. And that can use exactly the same numbering system that you already use, or we can start with new numbering systems when you implement an RFID system. And there are printers that can basically print and encode at the same time as well. So all of that's taken care of, and they're smart enough that once they encode and print a label, they'll send the data off to the database so that everything updates itself when you're commissioning new assets or even just replacing old labels for new ones. Depending on the use case and the technology as well, you may have secondary labels. So for example, if you have your sort of basic standard passive asset label, that will provide you with the UHF scanning capability to be able to sort of detect it from 10 or 12 meters away at the passive detection points. But you could additionally have something like an active tag for Wi-Fi or BLE or even GPS, which is giving off its own signals in addition to the passive tag. You've got the real-time location with 2-meter accuracy of the active tag. But then in the worst case scenario, if that active tag should become damaged or knocked off the device, or the battery dies after a few years, then you still have that passive label there as the fallback. So what is GS1 and how does it work with RFID in healthcare? So GS1 is the global standards organization that invented the barcode originally. And they've got a lot of standards in place now to ensure that as RFID is being adopted, not just in healthcare, but in other industries around the world as well, that everyone basically conforms to the same standard. So a couple of examples of ones that we use, there's something called a GIAI, that's your Global Individual Asset Identifier. It's basically a very long string that contains a couple of prefixes to identify what is it, so it's an asset. What organization does it belong to? So every hospital, for example, can have its own unique prefix registered with GS1 in their global database. And then as you break down through the prefixes, you get to the equipment number at the end. So the whole thing put together will identify it's an asset that belongs to this organization, and that is the asset number. You can even have sub-department codes put into that full string as well. So it's even within an organization, you can say this belongs to clinical engineering or IT or estates. But the full string as a whole is a good global standard then that helps you correctly identify who that asset belongs to and what it is. Generally, when we read those tags, we'll encode it through the software so that you're only worried about the bit at the end, the actual asset or equipment number. And that's generally the bit that will be physically printed on the label as well as just that 6, 7 or 8-digit number, whatever it is you need. But the actual microchip would then have that full string embedded into it. Another example is GLN, so these are global location numbers. And RFID works great with these because a global location number, which is assigned to a ward or a department, can also have an RFID tag embedded into a label on the wall or on the door. And we love this because the RFID scanning equipment, as it's moving around, if it's a mobile scanner, can read this tag from distance. It registers it as a global location tag, and then we can automatically update the software for the user to say, we believe you've entered this location, can you confirm this is correct? And it makes the whole experience a bit more seamless so that you can just walk into a department, confirm you're in the new location that it's picked up, and continue your scanning or auditing. And so there are a few other examples of that, but GS1 overall is about standardization, and not just for assets, but also linking the locations, the patients, the drugs. And it's really about tying that whole piece together of digitizing everything for that patient's journey. Heavily linked in with Scan for Safety as well, so an initiative that was rolled out across the NHS a few years ago. And yeah, just all about basically tying everything in to digitize the data and have it all to a standard that everyone agrees on. Okay, here's one of the main ones. So how much does an RFID system cost? Well, that can obviously vary massively depending on your use case. How many assets do you have? What sort of tags do you need? Do they need to withstand extreme environments or environmental factors? Do they need to withstand extreme environments or external factors? What sort of software do you need? Are we integrating to other databases? There's lots of questions that will generally run through with a new customer to explore what that use case looks like. But they can start from tens of thousands. An average solution might be somewhere between the sort of 50 to 100,000 mark. And then there are some solutions which push into the millions, to be honest, if they're highly regulated and an awful lot of infrastructure required. Last one we've got here is, can we and do we track people? Short answer is yes. So in the world of RFID, a person is treated as an asset the same as a physical device is. So there are a couple of ways we do that, and there are use cases where it's done primarily for safety. Sometimes there are use cases, but it is primarily for safety. Examples being in the oil and gas and mining fields, it's primarily about worker safety or lone working, especially over large areas. We need to know where they are if there's any issues. But in a healthcare environment, which I traditionally advise on, there's two aspects. One is staff safety, and the other is for basically patient efficiency and their whole flow and journey. So on the staff safety side, an example of that would be a staff badge, which is an active tag, so it has a battery inside. It can be a very discreet way if they're holding their badge and they feel under threat for any reason, or they need support, that they can just push a button on the back of their tag. That then sends a signal through the infrastructure to, for example, the security desk to say this tag has been pressed, it needs some assistance, and this is the location, time, and even the person that pressed it. Now that sometimes does raise concerns around the organization is going to track me, they're going to start timing how long I've been on my breaks or when I've been to the toilet, etc. And there are lots of things we put in place to make sure that doesn't have to be the case. For example, anonymized tags, it doesn't have to say who it is, it can just say that it's a member of staff and it's there for your safety if you need it. Some tags will also be programmed so that they only emit a signal when pressed for say 15 minutes, and then otherwise they go into a sleep mode, so it's not emitting any signal otherwise. And then from a patient perspective, there's a couple of things we can do. So we have things like patient wristbands. This can also be for security. If you have dementia wards, it can make sure that a patient can't just wander out of the ward. We can integrate with alarms or door locking systems to make sure that they can't just escape. But usually it's for efficiency, so things like tracking their journey. If they're a day case appointment, we can use basically their wristbands and the system to track where they are through their journey. We can even advise through the software what their estimated waiting times are to get to the next step, and even push alerts out to their relatives or loved ones to let them know roughly when they're going to be finished and can be collected. The final use case of this is baby tagging systems as well. So thankfully, it's not so much of a problem in the UK, but certainly in other countries, baby security is a very sort of high in demand system. So essentially, these are tags that go on the baby's ankle, and they are tamper-proof, they're water resistant, etc. And also, if it again gets too close to a door, it can integrate and lock those doors and set alarms and lights and sirens off if we need to. And that is the last one. So I think I have definitely been pressure tested here to run through all of the basics of RFID in a healthcare application. I think for me, there's just so many use cases that improves patient safety directly. And we've been doing this for a number of years now, and I've seen a lot of benefits, but there's still a lot more that it can do as technology to continue improving patient safety and efficiency. So I'm really looking forward to seeing how this technology grows over the next few years, couple of decades even, and yeah, continue to see it grow. It's a technology that always evolves and is just improving all the time. So it's a really exciting field to be in.